Hi guys, let's look at how questions can be asked on this. Really, these questions that are here don't cover everything that could be asked. I might be pulling few questions from past exams at some point to sort of like show you how these questions will actually be asked. I'm thinking about that now, so I might be doing that. But really, these questions, I'm going to put them here so that you can think about it and see how stuff is happening. Anyway, they say show that the roots of x squared minus x minus 7 equal to 0 are irrational. Pause the video, try to do it, and see how it works. So let's look at how you would interpret the question, right? For roots to be real and irrational, we need to calculate delta and show that it is greater than 0 and not a perfect square, right? It must not be a perfect square, right? Because remember we said if it's a perfect square, a squared rational, if delta is a squared rational, then we have rational roots. For it to be irrational, we must make sure that delta is not a perfect square. So that's really what you are doing. So you check that the equation is in that standard, put the equation in the standard form. There you go, you put it there, and then you identify the coefficient of x squared and x to the power 0. That's A, that's B, that's C. Substitute that into a discriminant formula, you find that this is 32. 32 is not a perfect square and it's greater than 0. So you have showed that. So if you were to plot that in a graph, this is what you were to get. You can see that the roots are really not falling perfectly into known numbers, right? And to conclude, this is really important. So now we have calculated that delta is greater than 0 and is not a perfect square. Therefore, we can conclude that the roots, number 1, they must be real. Number 2, they are unequal. And number 3, they are irrational. So you need to come up with all those things, right? Step by step. Following question: for which values of k with the roots of 6x squared plus 6 is equal to 4kx be real or equal? So we're looking at for where would they be real and equal. So again, let's look at how you would interpret the question. For roots to be real and equal, we need to solve for the values of k such that the discriminant is equal to 0. Why must the discriminant be equal to 0? Roots are real and equal when the discriminant is equal to 0, right? Are we happy with that? And then you just literally just go on and be like, you rearrange that into a standard form. There you go. You tell me what's your A, your B, and your C. You plug them into your discriminant, you set your discriminant equal to 0, you solve for k, right? You have your k and two values of k because that was sort of like a quadratic. And then you see if you were to substitute k back into that equation. Which equation is this? This is the rearranged equation. It's that equation. If you were to substitute k back and solve for x, would you really have the roots that they are talking about? You can see that x is equal to 1 for k is equal to 3, x is equal to minus 3 for k, it's equal to negative 3. We see that k minus 3, the quadratic equation has real equal roots, x is equal to negative 1. Right, so really the final answer is that for the roots of the quadratic equation to be real, and equal, we need k to be equal to 3 or k to be equal to negative 3. So really what's happening here is that you have two values of k where the roots could be equal, right? If you expand that, you can find that those are actually two x's, and here in Nalapa there's two x's for a different value of k, right? That's really important to spot that sort of like distinction and not try to say these are the two different x values. They are, yes, they are two different, but for this equation, if you were to let k to be equal to 3, you will get that, which is two equal roots, and over here you will also get two equal roots. So your answer would be for the roots of the quadratic equation to be real and equal, we need k to be equal to 3 or k to be equal to negative 3. Let's look at our next question. Show that the roots of x plus h multiplied by x plus k is equal to 4d squared are real for all real values of h, k, and d. Guys, do you want to think about that by yourselves? Look at how you interpret a question and look at how you check that the equation is in the standard form. So you'd have to think about how you would do that and make it into a standard form. And pause a video and go ahead with it. Try to do something. I promise you, try to do something. Don't try to wait for the answer. Just try to do it. Try to do it. So what you would have to do, you'll have to first multiply that. Let's first really think about interpret. Let's look at that. For roots to be real, we need to calculate the discriminant and show that the discriminant is greater than 0 for all real values of h, k, and d. Now, when you look at that, it's not clear how you're going to show that exactly. But when you get problems like these, do the normal thing that you do. Something from what you do is going to pop up. It's going to be like, it's going to pop up and you're going to be like, oh, okay, now I can see where I have to make this conclusion. So what you're going to have there, you're going to multiply that and all that, and this is what you're going to have. Right? So you're going to identify the coefficient of x squared, x, and x to the power 0. I refer to this c as the coefficient of x to the power 0. Think hard about why I do that. So a is going to be equal to 1 over there. B is going to be equal to that business over there. And c is going to be equal to that business over there. So if you write that as a discriminant, that's what you get as delta. For roots to be real, delta must be greater than 0. So we know that 4d squared must be greater than 0. You're taking something and you're squaring it. We know that it must be greater than 0. We also know that h minus k squared must be greater than 0. Right? Guys, I've dealt with a problem similar to this with you. That's an important observation. So then, if you take h minus k squared plus 4d squared, that must be equal to 0 or greater than 0. And we can therefore see that our discriminant is greater than 0. Right? So we have shown that the discriminant is greater than 0. Therefore, the roots are real for all real values of h, k, and d. Really, it is that simple, but when you deal with sort of like real, these are problems that are going to help you to think about that. But later on, you're going to be asked quite serious questions. And what I'm going to do is that when I start dealing with functions, that's where they can ask those things. When I start dealing with functions, just somewhere in the middle or at the end, I will put all sort of questions that can be asked from everywhere into one presentation, and then I'm going to go through the series of those questions and thinking about how you interpret them and stuff like that. So guys, you can copy that and see if you can do that, and copy that and pause the video and copy that and see if you can do it. I don't expect you to do them, but if you can, go ahead. Bye guys, all the best.